I'm Joshua Bardwell, and you're going to learn something today. Today I'm building a quadcopter, start to finish. So you're going to get all the usual tips and tricks that you get from my quadcopter build, see all the cool equipment and so forth, how to put it together. Yeah. But also, you're going to get to see a new quadcopter frame that is not on the market yet. In fact, it's looking for a manufacturer. I think it's pretty cool. I'm really excited to show it to you. One of the privileges of having a sort of popular YouTube channel is that I get to see a whole bunch of stuff from people that hasn't hit the market yet. And usually I'm like, oh yeah, that's really cool. And sometimes when it comes out, I review it or test it or give feedback on it. But very seldom do I see a product and go, wow, I want to be a part of that. And this quadcopter frame that I'm going to show you in this build is an example of that. Now, I didn't design this frame. In fact, I didn't really have anything to do with this frame except that the designer of the frame brought it to me and said, hey, I want to sell this frame. Can you please help me find someone to manufacture it? See, he designed it, but he's not set up to do mass production or customer service or any of that stuff. So before I start shopping it around to people, I just thought I'd make a video about it and build some hype. But I hope that the hype is is real, you know, not just hype. I really think this is a cool design, and I'll tell you more about it as we get into the build. And if you're not into the hype, well, there's a whole bunch of other, I mean, it's a whole quadcopter build, so I hope you're getting some knowledge and some value out of it, not just, woo, hype. All right. Let's take a look at the parts that are going into this build. We've got the aforementioned mystery frame, of course, the Emax 2306-2700 kV motors, Emax Avan props, Foxeer 35 amp BLHeli ESCs. I'm using these because they're the only 35 amp ESCs I've got, and those motors are real beasts. The TBS Unify video transmitter, X4R SB receiver, Foxeer Arrow Mini camera, and the FlyingLemon Kiwi V2 F4 flight controller with PDB. This is a beautiful motor in so many ways, but this was the build where I decided that the 2700 kV version is just too amp hungry. I'd love to try the 2400 kV version, but that's not what's going on in this copter. The FlyingLemon Kiwi F4 flight controller is an F4 flight controller and PDB combo. The Kiwi, the original Kiwi, I was a little bit hard on in my F3 flight controller roundup, but the V2 has addressed all of my complaints, like the lack of an SD card. It's got Betaflight OSD, and with a separate PDB, it gives you the option, you know, to use regular ESCs while still having current sensing, and you don't have to commit to a 4-in-1 ESC where if you fry one, you're screwed. The receiver that I prefer to use is the X4R SB, as long as there's size on the copter to do it. For really small copters, I use the XM Plus. The reason I like the X4R SB is that it has telemetry. Many people feel that if you have an OSD, you don't need telemetry, but I like to have voltage warnings on the Tyrannus in addition to the OSD, and I like to be able to do things like, now that we have Lewis scripting that'll let you change PIDs and video transmitter settings, you can't do that without telemetry. So I really want telemetry from my receiver. I prefer the X4R SB to the XSR because the X4R SB has the IPEX connectors, so you can easily swap out a receiver antenna. Some people may be surprised to hear that, given how much I hate IPEX connectors on video transmitters. But these antennas are much smaller and lighter. The pigtail doesn't pull on them as much. I think IPEX connectors on a receiver are a good thing, on a video transmitter are a bad thing. Many of you are really happy to see me using a Foxeer. I often use run cams on my builds, and people are always saying, hey, you should try a Foxeer. And I'm sorry, but I'm going to disappoint you and tell you I did not end up using this camera on the build. And the reason is that this is a mini version. So the Foxeer Arrow Mini run cam has a Swift Mini. And unless the frame is specifically designed to hold this size of camera, I don't think there's a big advantage. In fact, there's a disadvantage. The weight of this camera is basically the same as the full-size version, except you have to use an adapter. Now, in the case of the Swift Mini, RunCam gives you a nice little cradle that it fits down in that basically adapts it to the full size. So why not just buy a full-size one and not use the adapter? In the case of the Foxeer, they didn't have that kind of cradle. They just gave you a U-shaped camera bracket, and those things are terrible. So I bit the bullet. I said, I'm going to stick with the Foxeer, and I went to use the U-shaped bracket, and it just, I couldn't do it. So I'm not using this one, and I'm making the point right now that I don't think I would want to use a mini version of a camera unless the frame is specifically designed to mount the mini version, in which case, yes, it's very nice. It's not any lighter, but it's smaller and yada, yada, yada. Okay, all right, let's get into the build then. I'm going to go ahead and take the top plate off, and I'm going to take the standoffs off. So I'm just working with the bottom plate, so I have room to put everything together. If you start a build this way, do make sure that you pay attention to where the standoffs and the side plates are going to be, so that you don't end up routing a wire really tight and short and then not having enough slack to actually put the darn thing back together. This is a problem I have run into more times than I care to admit, and I've learned my lesson the hard way. Before you mount your motors, just make sure that your screws are the right length. I'm just going to press the screw through the arm, and then I'm going to just hold the motor down and see how far up into the motor the screw protrudes. And you can see there that it is not protruding into the bottom of the motor and is not going to touch the windings. I do this check on every build because, well, you just never know. One of the things I like about this frame is the way the end of the arm has been designed with these two little devil horns, you could call them, to help protect the motor. It's a little bit more weight than you would have if you had a little spindly end like the end of some of the Shendrone's frames, for example. But it does provide a little bit of extra protection for the motor if you get into a cartwheeling crash or something like that. I like to work outside in on my build, so I install the motors first and then work to the ESCs and then to the stack. Some people do it the opposite order. I don't think there's a really right or wrong way to do it, but this is the way that makes sense to me. So the next thing I'm going to do is I'm going to place the ESC on the arm in the appropriate location. I do soft mount my ESCs, not because there's any vibration advantage to the gyros or anything, but simply because it can keep the ESCs from being damaged. When the arm takes a whack, it's a lot of stress, a lot of vibration, a lot of shock, and it can actually knock capacitors or diodes off the bottom of the ESC. So I do soft mount the ESCs, and many people joke about that, but it's not for the reason that you think. Right here, I'm checking where the prop is going to hit the ESC if the prop gets bent down. It's a toss-up for me whether you want the prop hitting the ESC or hitting the wires. I personally, the props that I run don't seem to damage ESCs very much, and I actually prefer to have the prop hit the ESC if it gets bent down. Some people, because it'll cut the wires, but it'll just bounce off the ESC. Also, you can certainly cover the ESC with a piece of plastic or something to protect it. That's where I like to put the ESCs. Next, I'm cutting the wires to length and stripping them. I always try and leave myself just a little bit of extra slack here. It's easy to cut them too short and not have enough slack. So you can see I could have cut that maybe another millimeter shorter, but it's easy to kind of squeeze it up, wrinkle it up a little bit, and then you have just a little bit of extra slack in the wire for repairs, or if you've just screwed something up. You see how I pushed that down and made just a little bit of extra space there. So I'm going to cut them, I'm going to strip them, and I'm going to solder them. The steps of soldering, pretty basic here. This is not a soldering tutorial, but you're going to twist the wire so it all twists together and there's no little strands sticking out to make a bridge somewhere where there shouldn't be. Next, with a clean iron, you're going to tin the wire by putting a little bit of solder on it. The iron does need to be clean. You should have a shiny, clean tip. If it's got oxidation on it, it's not going to transfer heat well. Just putting a little more solder on that one. It just looked a little dry. I'm just checking my fit up here. That one's a little long, so I'm going to snip it just a little shorter. As I tin them, I don't want them hanging out over the ESC because any little drop of solder ball or blob of solder will fall on the circuit board, and of course that's no good. Now I've shortened it a little too much, so I'm going to strip it back a little. This is why I left myself a little bit extra slack, you see. There we go. Again, just adjusting the length here. I don't want them so long that there's a lot of naked wire hanging off the end of the solder pad, and I definitely don't want it extending over into the circuit board itself where it might make contact with something it's not supposed to. Now I'm tinning the pads of the ESC itself. If you have trouble doing this, your iron may not be hot enough, or you may not have a clean tip. These pads can be a little bit harder to tin because they're heavier. They have to carry a lot of current, so they're heavier, so they soak heat more. Now with my handy dandy hemostat, one of the most useful tools I own, I highly recommend getting one. I'm going to go ahead and hold this wire in place and just apply heat to flow and solder the joint together. And a nice, smooth, silvery ball is the result we're going for. If it's dull gray, it may have been overheated and the flux may have boiled out. And if it is not smooth, then it probably didn't flow properly. Especially if it has like a little soft serve ice cream cone pointy tip. That's not a sign of a good joint. You need to add a little more flux or a little more fresh solder and reflow that joint. Now I'm mounting the PDB. What you don't see here is about 20 minutes of fiddling around trying to figure out the right length of screw and whether I could use a rubber standoff for vibration isolation and whether it would fit under the top plate, etc., etc. And the bottom line is I decided that it would have to hard mount this board. The combination of PDB and flight controller, which are designed to, they plug together, means that I have to keep the spacing between them very precise, and there's just no way that I could figure out to soft mount it. So fingers crossed that this works okay without soft mounting. That's a function of the flight controller, not the frame though. You see me putting the screw up through the bottom here and putting on a nut. These come with the frame. The nuts are very nice because they provide a little bit of spacing so that the PDB doesn't short out against the frame and make the magic smoke come out of your electronics, and it also holds these screws in place. These screws actually double as arm screws, so they are holding the arm in place. The arms are 5mm carbon, and you'll see that they completely fit together underneath the plate, so there's no empty space underneath the plates where the plates themselves might be unsupported. So I'm not real worried about transmitting any shock to the flight controller or anything like that. Now I'm installing the PDB for the FlyingLemon Kiwi V2. This comes with it. And you can see I'm having a little bit of trouble pushing it down over the screws. It helps if you loosen the screws just a tiny bit so they've got a little bit of flex to them so that you don't have to, well, I got it. But if you can get those screws just a little bit loose, that's a good idea. I didn't want to do that here because because those screws are also holding the arms together. So I wanted to make sure they were good and tight. And now you can see me fiddling around with these standoffs, trying to figure out what the right size of standoff is to use with the FlyingLemon Kiwi. The Kiwi comes with a set of standoffs that is right to use, but I set them aside somewhere and I lost them, so I have to find my own. And the right way to do that is to have one of these M3 standoff assortments. Get them off of Amazon. I'll put a link in the video description. It has various sizes of standoff, and digging around in this particular one, I found the standoff that I need. Now I'm going to tin the pads on the PDB, just get a little bit of fresh solder on each of them. You might be a little unused to how they've done the negative pad. You can see here it's not just a single pad, but it's a visible trace all the way around. They're all like that, it's just usually it's covered by solder mask. No big deal, just put some solder on there just like usual. And I'll go ahead and tin the signal pads as well. Next, I'm going to cut the Esc Signal Wires to length and strip them. These are nice silicone wires. It's very easy to strip them with your fingernails. I'm going to twist the wires together and tin them, just like I did with the motor wires. Very important step. I'll cut these shorter before I solder them up. This is much more exposed wire than we need. And it's easy to leave slack with these little thin wires. There's no real space penalty to making them longer than you need. So give yourself plenty of slack. Not so much that it's sloppy, but give yourself plenty of slack so when you solder them up, if you need a little more, you're not screwed. I like to route these wires coming out from the center line. I'm just going to hold it in place, apply heat to flow, and the joint will be complete. You can see I'm bringing the wire up from the center line though, and then out so that the wires sort of are tucked into the center of the board as opposed to sort of falling out from the outside. And now, having realized the mistake I was just about to make, I've installed the side plate, and I'm routing the wires around the side plate of the frame, so like I told you at the beginning, so I don't accidentally get myself in trouble and route a wire where it can't go once the frame is fully assembled. So yeah, don't do that. Here, I'm checking this wire for length, figuring out how I'm going to route it, and snip, strip with your fingernail, twist, good neat twist there, tin, cut to length, and solder. I'm going to twist these guys back together before I solder them up. I do that mostly just for neatness. Some people claim that there's an advantage to noise protection against electromagnetic noise. I'm not even going to touch that topic now, but it does make for a much neater build. You'll see me going to some effort here to get this wire to lay exactly in the center of the pad before I touch it with the iron. Good fit up makes for good soldering. See, it's off to the side now, and I don't want to hit it because I'm not going to be able to push it over. What I'm trying to do here is flow the joint, and while the solder is wet, move it to the center of the pad. But you can see that didn't work. Here, pardon the back of my head. You can see that didn't work. It's off center, and now I'm fixing it. Well, anyway, let's move on. There we go. Perfect. And I'm going to use the same technique for the power wires. Again, I'm routing from the center of the board out towards the edge, and I'm leaving myself a little bit of extra slack. I'm going to cut it to length, strip it, twist it, tin it, and solder it up. If the wire and the pad are well tinned and you hold the joint, hold it in the exact right place, exactly where you want it to be, then when you apply heat here, it should flow and just very easily flow together with very little stress or work. Successful soldering is all in the prep. The actual touching of the soldering iron to the joint is like the least important part in some ways. And that is going to bring us to the end of this video. We have soldered up the motors, the ESCs, and the PDB. Hope you've enjoyed it. Hope it's been educational. If you have any questions, definitely leave them down in the comments. Thank you for watching, and as always, happy flying.